All right, here we are, 5'9", temperature. Make a table. Yeah, we're not doing that. I'm just curious what the fun big lesson was, but we were gonna do that anyway. Anyway, this is it, the last one. So our objectives today are pretty much to convert between the two measures of temperature here. Anybody know what the third measure of temperature is called?
Celsius? No. Celsius. Fahrenheit?
I'll give you a clue.
Celsius. Fahrenheit.
Well, F is Fahrenheit, C is Celsius, it starts with a K.
Chemite. Kilometer. Kilomite. Temperite. Chemical. Kelvin. Kelvite. Kelvin. Kelvin from Kelvin.
Kelvin. You've never heard of a Kelvin?
No, but I've heard of Kelvin from Home Alone.
Right. So,
That's heaven.
well, anyway.
Kelvin. Oh, that's heaven.
Anyway, that one, you'll encounter it. It's more high physics uses Kelvin. It's the standard unit measure for things. But yeah. Anyway, Kelvin's not part of our deal today. But really, get right to it. This is the whole thing right here. You see a couple numbers, and if it happens to be in degrees Fahrenheit, like the first 5 are, what we're trying to do is turn them into degrees Celsius. And vice versa. If I tell you some measurements in Celsius, you convert it, tell me what it would be in Fahrenheit. It's more like the metric unit. It's Fahrenheit's the weird one, not Celsius. Fahrenheit's the weird one.
Fahrenheit is high, hot, low, cold.
It's you need to learn. Everybody in the world in this plan, like a lot of USA things, are different, but
Celsius is okay.
Nevertheless.
0 degrees Celsius is 32 Fahrenheit. And like negative 70.
we'll work through some. So, really, there's two formulas that are going to be popping up here today. There they both are, right there. We'll practice both, see how they work. You do not need to memorize these. These are provided to you on the quiz and test, written out. So degree, you'll see this exactly. You don't have to memorize them. But making sure you're using the right formula. And that can be more challenging than, I guess, I would think. And, but. So let's go over here. I'm just going to start with number 9 here. It says 60 degrees Fahrenheit. My question, of course, is degrees Celsius, how many is that? So we have our two formulas here. And this is, again, it says it right here, estimate, temperature estimate. This is not the exact formula for it. It's close enough. In addition, if you look even closer, maybe hard to see, I'll zoom in on it here. Get in there. There you go. See that there? So those aren't technically equal signs. Those are about signs. That's like the estimating equal sign in a way. But again, it's not, because this isn't the exact formula. The exact formula has a few more decimals and stuff in it, but it's close enough. Estimate. So we're going to get close here. For all practical purposes, we're going to solve and be done with it. But for those that are paying extra close attention, this is not a perfect, this is not exact. So when we figure out 60 degrees Fahrenheit is Celsius, we'll get an answer. It'll be close, but it will not be exact. Okay? And that's all right. Close enough. Cool? So whenever you see those symbols, you won't see them much, at least in middle school. That's what they mean. They mean about, or close to, or estimate, stuff like that. Okay. So the key here is we got two formulas. I got this formula. It says this. And subtract 30 and then divide by 2. And then I got this one. And it says this. So that's how they wrote them there. Okay. So, fuzzy. There, focus. So I have 60 degrees Fahrenheit. I want it in Celsius. Now the question becomes, which of these two formulas do I want? So what you need to ask yourself for to help you pick the right formula is ask yourself, what am I solving for? What am I trying to figure out?
What is the degrees in Celsius?
The degrees Celsius. So basically, that's the one I want. So which of these formulas is set up where if I plug in my Fahrenheit value, that all my order of operations on one side, and the only thing left is what I'm solving on the other.
The top one?
Top one?
Yeah.
Everybody agree with that or not so much? Yeah, he is absolutely correct. This is the formula I would want to use because what am I trying to solve is whatever's on one side of the equal sign. I am trying to figure out how many degrees Celsius it is. I'm not solving for degrees Fahrenheit because I already know what that is. I already know what that is. So this is the one that I would want here. If I don't know my degrees Celsius, that's what I'm trying to figure out. So to figure out my degrees Celsius, I'll just write the formula again down here. Same thing that I had up there, is I take my degree Fahrenheit and basically I just plug it on into the equation there. Because I'm trying to figure out how many degrees Celsius it is. So how many degrees Fahrenheit is it? It is 60. Whatever my degree Fahrenheit is, I subtract 30 from that number and then I'll divide by 2. So PEMDAS rules apply. So first thing I do is in the brackets here, right? 60 minus 30 is,
30.
and I still got divided by 2. 30 divided by 2, 60 degrees Fahrenheit is the same thing as 15 degrees Celsius. Oops. Number 10. All right, feel free to give that one a shot. I'll walk through it. Now I have -8 degrees Fahrenheit. -8. So now my question to you is, what is that in degrees Celsius?
Can you do it?
Oh, -8.
-8, right. So same formula should work for us because once again, we're trying to figure out our degrees Celsius. That's what we don't know. That's what I'm solving for. So same exact formula here. And then again, now let's start solving the equation here. So plug in what I know to be true. Okay. So Fahrenheit's 8 below, -8. Subtract 30, divide by 2. If I rewrite as an addition problem, plus a -30, I see that the signs are the same. So I should be adding the values together. 30 plus 8 is 38. Carry the sign. And then divide by 2. And then solve it. 38 divided by 2 is 19. Odd number of negatives. Negative outcome. -8 Fahrenheit is the same as -19 Celsius. Plug it in, solve, divide, there you go. All your answers should be integers today. There's no decimals, no fractions in any answers at all. No decimals, no fractions. Okay, we're going to practice some more of these, I promise. But let's look at number 14. And this time, I got 7 degrees Celsius.
Don't copy me.
So here's what we just did. We had a couple Fahrenheits to Celsius. We applied the same formula both times because we were solving for the same thing. We're trying to figure out what it is in Celsius. So, as you would probably expect, we need to use the other formula now, because what are we trying to figure out? Well, this is what I'm trying to figure out, my degrees Fahrenheit. How do I do that? Well, what I do, write out my formula here. This one's not written super well, but what it is I take my degrees Celsius, I'm going to rewrite the formula, whatever it happens to be, I multiply it times 2, and then I just add 30 to that number. So I just rewrote the form. This is what we're doing here. If you didn't quite catch what this is, just I wrote it how the book wrote it, okay? But that's however many degrees Celsius you got, multiplied times 2, and then add 30 to it. So now I can go in. I know how many degrees Celsius it is. It's 7. And then I'll multiply that times 2, and then I'll add 30 to my answer. So PEMDAS rules applies. This one's pretty easy. It's just straight left to right. 7 times 2 is 14, plus 30. And then 14 plus 30, 7 degrees Celsius is the same as 44 degrees Fahrenheit. You can help yourself slightly here if you understand. 32 degrees is freezing, right? How many degrees Celsius is that? Right.
I mean, that kind of makes more sense.
So you can use that here because if I have 7 degrees Celsius, right, going up, you should expect this to be bigger than 32 too. 44. Answer's good. So if I get an answer that's like -8, smaller than 32, well, I should expect, again, as we're going down here, they're going to go in the same direction. So this is kind of the magic number here. 60 degrees Fahrenheit, that's above 32. That'll give me some sort of positive Celsius. Basically, if I get under 32, I'm going to have a negative Celsius, and if I'm above 32, I'll have a positive Celsius. And if my Celsius is positive, then my Fahrenheit's above 32, and if it's a negative Celsius, then my Fahrenheit's below 32. So you can just use that, again, just to kind of make sure do my answers make sense. If you just understand that, you don't have to do any math. You already did it here, but just trying to verify, does this answer make sense with the numbers? You could kind of use this here and realize that both of these are going to go up or down from this spot here. Okay. Why don't you guys try number 15? -21 degrees Celsius. I'll work through this one and then I'll give you guys some to try.
Whoa.
Okay. It's not hard.
So would I expect my final answer to be positive answer or negative answer? Right, negative, because again, 0, 32, down to -21. Anything, this is going to definitely be reduced here. So
Celsius numbers are so low.
they have a lower range, that is for sure. So, I mean, most parts of the world are between 30 and -30 Celsius most of the time. All right. So plug it in, degrees Fahrenheit, whatever my degrees Celsius, I'll multiply times 2 and add 30. So my degrees Celsius is -21 times 2 plus 30. So -21 times +2 is -42 plus 30. And to finish it off, signs are different. Greater absolute value, subtract lesser absolute value. Carry the sign from the greater absolute value. -12. +12.
Oh, you did. Gosh, I did that. -12 degrees Celsius.
Right, so just plug in whatever the value is, multiply it times 2, odd number of negatives, so negative outcome. Add them, signs are different. Use the rule for when the signs are different, subtract, carry absolute value stuff. And there we go. Okay, all right, 4 for you guys. Try number
90.
27.
21. -4 degrees Fahrenheit. Number 25. 5 degrees Celsius. Number 22. 114 degrees Fahrenheit. And number 26. -30 degrees Celsius. So 4 problems. I'll write the formulas you need out here. So if you're finding Celsius, take your degrees Fahrenheit, subtract 30, divide by 2. If you need to find your Fahrenheit, take your degrees Celsius, multiply it times 2, and then add 30 to it. So there's your 2 formulas you'll need. So figure out which formula you need, apply the formula, solve the formula. 4 problems. 4 problems, 4 sticks.
So when you're subtracting 30, do you make the 30 a negative?
If you want to rewrite it as an addition problem, you can do that. You're right. I could, yeah, so if you want to write it out this way, if it helps you, adding a -30 divided by 2. This is okay too. This and this are the same here. I should use second level brackets though when I did, so. Remember, all your answers are integers, no fractions or decimals or anything should show up on you today.
Why do you do that? You're like,
Why don't you?
I don't know why do these?
Why do I?
Yeah,
Why do you ask that question?
I don't know. Why would you ask me about asking that question?
All right. Chapter 6, for what it's worth, is a long chapter. I think there's 6 quizzes in that chapter.
Aren't there like 16 lessons?
Yeah,
I
there
think there's
is.
18 lessons.
Oh, that's such a long test.
Okay, Mr. Melcher, I'm gonna fail.
Well, there's 17, not including the bonus one.
My first lesson back on Thursday will warm up our brains quickly. Rules of divisibility.
I'm gonna fail that test. See, you're not gonna fail it.
I'm not.
No,
You're
no.
gonna flunk it.
I'm gonna flunk it, yeah. Yeah, man.
There's not a lot of new stuff in chapter 6.
Wait, that's the next chapter.
When you do Fahrenheit, does it always have to be a capital F?
Yeah. I'm not gonna
I'm not gonna look
break you
it up.
guys around on that type of stuff in 6th grade, but
About what?
yeah, a lot of, mainly in formulas, capital letters are almost exclusively used for anything. I mean, the temperature, I mean, area, volume, all capital, it's generally used. The small letters are reserved for variables or different parts inside the formula. Like, If I found area of a parallelogram, length times width, the A is capitalized, that's the formula for area, but the length and width are not. Those are variables. They could be different things here. So something like this, formula based, it will be a capital letter. So. Give you guys another minute or two, and then we'll pull out some sticks and see how you did.
It's 21, 25, 22, and what, 27?
21, 25, 22, 26. There's the other two. Savannah, any note cards you make, you can use in that quiz tomorrow. Anything at all? Yes. The formulas itself, nobody has too many issues with them. Again, the big problem is selecting the right formula. That's the problem. So if you're able to get through that, again, solving them is not really a problem for most people. It's just getting the right formula. Okay, so instead of writing out the formulas over and over and over and over, number one, that formula. Number two, that formula. So that way you can just tell me which formula we need to use here. All right, 21, Sierra. No. Okay, that was a good start. Sig, which formula are we using? Number one or number two? This one, yeah. Which formula? Number one or number two?
One?
You're sure?
Wait. Yeah. Wait.
Dom, confirming your.
You sure?
I heard a yeah just from somebody else all of a sudden. Yeah, you're right. Because what am I solving for? Again, it's always asking yourself over here. Because again, if I try and put it in the -4 here, well then, it's just, so, right. So then plug it in here. I got -4 plus a -30, or however you want to do it, divided by 2. So -4 subtract 30 is? Or add a -30, whatever you want.
I got, 1 sec. Wait. Wait, did you do it? Yeah. Oh, -34?
Okay. And what do I do with that?
Yeah. Divided by 2?
Uh-huh. And final answer?
-17.
Right.
Oh, I got -2.
That's it. -17. You got it, Sig. Good.
Buddy.
All right, 25. Damien, number one or number two?
Which one did I do? I did number.
Why is it taking so long?
What? I did the number 1.
What would you do?
Or
Nope.
not number 2.
Right, because what don't I know? That's what I don't know.
Yeah.
So plug it in. So 5 times 2 plus 30.
10 plus 30 is 40.
Mm-hmm. Final answer, 40 degrees. Again, this is a nice one because we know 0 is 32. So I went from 0 to 5. I would expect this to go up a little bit too. And it did. It did go up a little bit from 32. So this one went up. This one went up a bit too. So we're in the ballpark here. I would expect 5 degrees Celsius to be fairly close to 32. Not super close, but I know 0 is 32. 5 is going to be something a little bigger than 32. And that's good. All right. Good. 22. Dom, which formula are we using? Number 1 or number 2?
Number 1. And that was 3 boys in a row.
Right. Yep. I wasn't even noticing. So plug it in here. Number 1 is correct, degrees Celsius. So 114. There's my F. Minus 30 divided by 2. All right, Dom.
You changed the subtraction into addition probably. So, yeah. And then, that's 84
Yep.
divided by 2. And then you get
Bada bing, bada boom. Just like that. Good. All right, 26. Evangeline, which formula we want?
Huh, I didn't realize there was another one. Oh, no.
I guess I better just make one more up for Brooke.
Let's go.
Brooke, you can do.
No, don't give me a hard one. Don't give me a hard one. Please.
Which one do you want, Brooke?
I want 17.
Fair enough. 17. Let me try that.
Okay. So,
Right. Then we all get ones. One more. So, Evangeline, Brooke, you're up, but sure, practice this one too. See what you get. We got a moment.
Save. Oh. Cooking. I like to cook.
okay.
Sorry, don't cook.
Done.
Got it, Brooke? All right, which formula are we using, number 1 or number 2?
We are going to be using number 2.
Right, because we're trying to figure out degrees.
Okay. So
So,
first we do 83 times 2, which is 166. Okay. And then 166 plus 30. Wait, better. Yeah. Which is 196. And then 196 degrees Fahrenheit.
you got it.
That's a hot day.
Yes, yeah, stay inside. I would not go outside on that day. All right, Evangeline, which one are we using, number 1 or number 2?
2.
Right, number 2, because we're trying to figure out our degrees Fahrenheit. So plug it in. Okay,
First, I multiplied negative 30 times 2, which is 60.
negative 60.
Negative 60, and then plus 30, which you would subtract it because of different signs.
Yep,
is
signs are different.
negative 30.
All right, get a 30, carry the sign from the greater absolute value. Final answer, negative 30 degrees Fahrenheit. Okay.
So negative 30 degrees Celsius, negative 30 degrees Fahrenheit.
That's where the line they meet up. You knew it would happen somewhere, and there it is, right there. Truth. Okay. So just to be clear, real quick on the homework, I'm gonna just make sure we understand the first part here. So the first part in your homework, 1 through 12, looks something like this. It'll say 17 degrees, this, and then it'll say drops, I don't know, 6 degrees or something. So there's a couple different ways as I see the word falls, rises, drops, and climbs. So 2 of those words mean to subtract. Which 2 words?
Drops and like declines.
Drops and falls mean to subtract. Basically, I'm going down 6 degrees, and of course, rising or climbing is we're going up. We're adding, right? So basically, this is where it is. It's 17. It drops 6 degrees. So I'm just going to subtract 6 degrees. What's our temperature that we're at now?
9 degrees.
17 minus 6?
No, like 11.
It's 11.
Oh yeah.
Minus 6 is 11 here. All right, you guys try one more. Negative 18 degrees Celsius rises 12 degrees. So where are we at? What's the new temperature?
30. No. Negative 6.
It rises.
Yeah, it's also negative 18 though.
Right, positive 18 would get up to 30, but negative 18, and we never even made it to 0 because it'd have to rise 18 degrees to get to 0. But key word here is when you see drops or falls, you're subtracting. When it rises or climbs, you're adding, right?
Yeah.
Signs are different. So subtract greater absolute value. It has risen up to negative 6. So You'll have to do that the first 12, add or subtract, interpret accordingly. 13 through 24 is use the thing. Your formulas, by the way, if you when you need them, they're right up here in your top right corner.
Yeah,
See them?
yeah.
So you don't have to write them down. They're right there for you. 13 through 24, though, apply the formula, then some word problems. Okay? So homework, page 55. All right, Sig, hit it.
Make sure to like and subscribe.
Very good, thank you. Very good.